Hello chemists, today we're going to learn about delta H, which is enthalpy. So for this, you will need an enthalpy chart, which will be provided by your teacher. Not all have the same values, and you will need a calculator. I hope you enjoy the video. We're all struggling in Dr. C's class, so don't worry, I got your back if you're struggling. I know Dr. C is the only one watching this, but hey, you never know. Enthalpy is the measure of heat in a system held at constant temperature. To calculate enthalpy, we will use the formula delta H equals delta H products minus delta H reactants. So we need this formula, and we also need our enthalpy chart. All right, one thing to know with your coefficients. So say NO2. You're going to take the standard enthalpy. So for NO2, the standard enthalpy is 34. So you're going to plug in 34. Now you're going to multiply the number of moles you have to your standard enthalpy. So it would be 3 times 34. That would calculate your total enthalpy. Calculating our enthalpy, we are going to use kilojoules per mole in our answer. For our formula, enthalpy products minus enthalpy reactants. So this minus these reactants. So first we're going to do our products. So looking at our chart, NO2 is 34 kilojoules per mole. Right? However, that is only for 1 mole. We have 2. So our coefficient is 2, so we're multiplying the whole thing by 2. Now we're going to subtract our reactants. Remember, there's 2. So now we're going to look up NO. NO is 90, but we have 2 of them. So I put my brackets. Then we're going to multiply 2 times 90 plus oxygen, which is 0, plus 0. So that really doesn't help. So now, again, basic math. Multiply 2 times 34, which equals 68, minus 2 times 90, which gives us 180. Now 68 minus 180 is negative 112 kilojoules. Hydrogen reacts with oxygen to make water. So this is also a synthesis reaction. So now we're going to look at our enthalpy chart, right? That is our key tool in helping us find the enthalpy of the reaction. So remember, it's products minus reactants. So we're going to look at H2O. We're going to find H2O on our enthalpy chart. All right. Now, notice our coefficient is 3. For just water, for just one water, the total is negative 286. However, there are 3. So we're going to multiply that total by 3. So multiply by our coefficient. And then we're going to subtract our reactants. So hydrogen, H2, is a gas, and that's 0. So even though there are 3 times 0 is still 0. So 0 plus O3. We're going to look at our enthalpy chart where it says O3, and we get 143. Okay, so now it's basic math. 3 times this, then you're going to subtract. your reactants. So plug in 3 times negative 286, which is negative 858 minus 143. Minus equals, that's going to give you negative 1001 kilojoules. Formula is enthalpy enthalpy of our products minus our reactants. So we're going to add this all up. We're going to look at our chart. All right, and we're going to add that to C2H2. That tells us it's 227. All right, we're going to subtract that from our reactants, which is CaC2, which is negative 63, plus, now I would put brackets, 2 times H2O, so negative 286. So here we have it. So now it's just basic math. So we're going to do negative 987 plus positive 227. That gives us negative 760. Now, we're going to solve inside the brackets first. So we're going to do this first. So 2 times negative 286 equals, so negative 63 minus 572. Now we're going to solve inside this. Then we will distribute the negative. So negative 572 minus 63 equals a negative 635. Now, once we do that, we're going to distribute. So we're going to simplify everything. Now, we need to distribute the negative. So it's going to be negative 760 plus negative times negative is a positive 635. We're going to put that in our calculator. Negative 760 plus 635, which gives us negative 125. That's in kilojoules per mole. And that is our enthalpy. And that's how you find the enthalpy of a reaction. I hope you enjoyed the video.